Hello dear students, this is our second lecture on classical mechanics and our main focus will be only, so we'll discuss some of the basic concepts and then we'll take different problems or different examples related to those concepts in classical physics. Now first of all in previous topic तो जो इससे पहले हमारा जो टॉपिक था उसमें हमने डिस्कस किया था द डिग्रीज ऑफ फ्रीडम हाउ वी कैन कैलकुलेट तो हम डिग्रीज ऑफ फ्रीडम डिफरेंट सिस्टम्स के लिए कैसे कैलकुलेट कर सकते हैं तो उसमें हमने बहुत सारे प्रॉब्लम्स देखे तो एंड उसके लिए हमने एक फार्मूला लिखी थी डिग्रीज ऑफ फ्रीडम निकालने के लिए and in addition to that in the previous topic I already told you that in maximum cases हम कहते हैं कि जो हमारा डिग्रीज ऑफ फ्रीडम होता है so that's equal to the generalized coordinate. Now as the title is this is basically the generalized coordinate. तो इसकी जो definition है these are basically set of independent coordinates that basically that can describe the motion of a particle or a system of particles completely. तो अगर हमारे पास एक मतलब पार्टिकल होगा तो अगर हम डिफरेंट कोऑर्डिनेट सिस्टम्स यूज करेंगे एंड एंड वी नीड टू चेक वेदर दीज set of coordinates that we will use whether these are independent or not. So they should be independent. Then we can say that those set of coordinates are called generalized coordinates, right? So so these generalized coordinates are usually तो हम usually in classical mechanics में हम इसको denote we represent these generalized coordinates by q1 q3 तो दैट मीन्स अगर हमारे पास n नंबर ऑफ पार्टिकल्स हो गए क्योंकि हमने पहले लेक्चर में बताया था मैंने आपको कि हमारे पास सिंगल पार्टिकल हो सकता है या हमारे पास ए सिस्टम ऑफ पार्टिकल हो सकता है राइट तो दिस इज बेसिकली द जनरलाइज्ड कोऑर्डिनेट्स फॉर n नंबर ऑफ पार्टिकल्स राइट नाउ इफ आई टेक अ सिंपल एग्जांपल अगर हम एक सिंपल एग्जांपल लेंगे अ पार्टिकल इज मूविंग along a circular track तो हम देखेंगे कि so what will be the corresponding generalized coordinates to that particle which is traveling along a circular path. तो पहले एग्जांपल अगर हम लेंगे तो फर्स्ट एग्जांपल विल बी if I consider that particle traveling along a तो जो पार्टिकल है तो ये सर्कुलर पाथ में ट्रेवल कर रहा है सो दैट मीन अगर हम अगर हम एक इफ आई टेक दैट एक्स वाई जी कोऑर्डिनेट सिस्टम तो दिस फॉर एक्स वाई एंड z so that means जो मोशन यहाँ पे पार्टिकल की है so it is going in xy plane so this is the motion of the particle तो पार्टिकल मूव हो रहा है ऐसे so this is particle so it is moving in that circular path along the circular path but in xy plane right so that means इसको मैं लिख सकता हूँ this is equivalent to तो इसको मैं ऐसे भी लिख सकता हूँ if I have this coordinate system that's x y and z so I can denote it by this direction तो ये हमारा पार्टिकल है having some mass m right and this particle अगर मुझे इसकी लोकेशन देखनी होगी if I specify the motion of this particle so this can be denoted by that x and y because I am saying that तो मैं कह रहा हूँ कि जो पार्टिकल ये मूव हो रहा है in xy plane and the rotation axis will be z axis right so ये रोटेट होता है xy plane okay so in that case so this अगर मैं यहाँ पे so this is the origin so this is simply that position vector or vector. So this is the position vector corresponding to this particle and this position vector I can write that so this is equal to xi cap y. So that means हमारे पास position vector है so can this coordinate system can we describe this particle completely इसके हम so can we describe this particle completely or not so this is our meaning right क्योंकि अगर हमारे पास position vector है because it's a function of x and y तो हम we can calculate velocity तो यहाँ से velocity कैलकुलेट कर सकते हैं. सो दैट इज बेसिकली dr by dt. So that's equal to, so that means हम देख सकते हैं, हम कह सकते हैं कि इसकी वेलोसिटी है. सो दीज आर द कंपोनेंट्स ऑफ वेलोसिटी दैट वी एक्स एंड वी आर, राइट. सो दैट मीन हम वेलोसिटी देख सकते हैं इस पार्टिकल की विच इज मूविंग अलोंग ए सर्कुलर पाथ having that fixed radius r. Okay, or we can say that the acceleration will be also, so that will be equal to ax r plus a by j, or we can say that the corresponding linear momentum, that's most times velocity, so that is m vx I cap m. So that means अगर मेरे पास पोजिशन वेक्टर होगा एक पार्टिकल का विच इज मूविंग, आई एम टेकिंग दिस एग्जांपल, यहाँ पे मैं कह रहा हूँ कि पार्टिकल मूव हो रहा है अलॉन्ग ए सर्कुलर पाथ. तो यहाँ पे मैं कह सकता हूँ अगर मुझे पोजिशन वेक्टर पता होगा, मैं वेलोसिटी कैलकुलेट कर सकता हूँ और आई कैन कैलकुलेट एक्सेलरेशन या मैं मोमेंटम इसका देख सकता हूँ. सो दैट मीन्स आई कैन हैव ऑल द इंफॉर्मेशन अबाउट द मास ऑफ दिस पार्टिकल विच इज मूविंग अलॉन्ग ए सर्कुलर ट्रैक. So that means I can describe. So that means once we know the position vector, अगर हमें position vector पता होगा, so that means we can determine all the information regarding about this particle, right? Now this is basically, so far this definition is concerned. अगर हम definition की बात करेंगे, तो वो हमें कह रहा है कि these are basically generalized coordinates are a set of independent coordinates. So that means जो मैंने coordinate system यहाँ पे use किया है, तो जो हमारा coordinate system है, so that is our xyz coordinate system, right? With its rotation axis as z axis, right? So that means this coordinate system, whether these x and y are independent of each other or not. Okay? So far the definition of generalized coordinate is concerned. So I am saying that those coordinates should be independent. ये independent होने चाहिए. They should not depend upon one another. Second case is that they should describe the system completely. They should describe the system or a system of particles completely, right? Although यहाँ पे I'm getting all the information, मैं कह सकता हूँ जो particle होगा इसकी velocity क्या है और इसकी acceleration क्या है और इसका momentum क्या है, so that I can calculate. So once I know the position vector. Now the second case is that अब हमें पता whether can we say that x and y are independent of each other or not, right? Because if we see that, because I'm saying that this is, it is rotating, the rotation axis is z axis, and this particle is moving in the xy plane. So that means this is simply that circle. The path of that particle is a circle. So that means this we can have then. So we can say that r square will be equal to x square plus y square, because this is the equation of circle and the origin it is x minus xa ka whole square plus y minus y ka whole square equal to radius, because this radius is fixed. Okay, so that means here this x and y, these are not independent because these are related by this radius vector r square. So we can say that these x and y are not independent, they are not independent of each other, right? So what should we do then? How we can identify then the generalized coordinates? So this is very important. तो मैं नहीं कह सकता हूँ कि ये जो मेरा x and y ये generalized coordinates हो सकते हैं. So for the definition of generalized coordinate is concerned. So that means what we can do, हम क्या कर सकते हैं, हम transform कर सकते हैं. So we can go from Cartesian coordinates to cylindrical coordinates, right? Because it's having, अगर मैं कोई भी circle यहाँ पे draw करूँगा, so that means this radius vector will be fixed here, right? So what I can do now, so I will use now cylindrical coordinates. So we can say that to find, तो इसको मैं short form में GC भी लिख सकता हूँ. GC stands for generalized coordinate. So in order to calculate those generalized coordinates, we will shift. तो हम क्या करेंगे? We will go from Cartesian coordinate cylindrical coordinate. तो हम cartesian coordinates से cylindrical coordinates की तरफ जाएंगे, right? So we can transform this, right? So let us see that. So that means when we discuss, जब हम cylindrical coordinates की बात करें, so we are assigning them. So in cylindrical coordinates, I am saying that these are assigned by rho, phi, and z, right? So first of all, because x and y are the Cartesian coordinates, I am very much aware about that. Similarly, I can define what's basically rho, phi, and z, right? So that means, so far this z is concerned, so this is the rotation axis. So particle move हो रहा है along a circular path, and let's have a look on this rho. What is rho here? So rho is basically, so that means if I draw these Cartesian coordinates, okay, so we can say that the particle, the track of the particle, so that's basically a circular, right? Which is having some mass m, right? So this is our xy coordinates, x, y, z. Okay. So let's talk about this. What's basically a rho? So rho is basically, so that is the perpendicular distance, or you can say that this rho is basically, so ये हमारी perpendicular distance है from the x-axis. Okay. So this is the perpendicular distance from the x-axis, which is simply the radius of that circle. Okay. So we can say that. So this is our the perpendicular distance, and this is denoted by s. Okay. Or you can say that यहाँ पे मैंने कहा कि this is rho, so I can represent it by rho. So that means this rho is basically the perpendicular distance of a particle, perpendicular distance from the x-axis. Okay. Now similarly we have phi. So phi is basically the angle that it makes along that x-axis. So that is basically this phi. So this is phi. Okay. So this phi is basically what's called the azimuthal angle. Right. So phi को हम azimuthal angle कह रहे हैं. It is basically the angle that's made by this x-axis with this rho. Right? And this z is basically axis of rotation, right? So that's very clear because मैं यहाँ पे कह रहा हूँ कि जो particle move हो रहा है in xy plane and this rotation axis is fixed, right? Okay. Now let's have a look. So for a circular path, अगर हम circular path की बात करेंगे, तो for circular path, so we're saying that z equal to 0. So that means because when we have three axes, so that means अगर if this is z axis, this is x and y, so that means ये move हो रहा है, तो ये जो circle travel जो ये track बना रहा है ये particle, तो ये at the origin of that this xyz axis, right? So that means it is moving in the xy plane, but with z equal to 0, right? So that means it is moving that circular path, but at the origin of that this coordinate system. Okay, so that means we can say that z equal to 0. And what about this rho? Rho is basically that what I wrote here. This is the perpendicular distance. Perpendicular distance from the x-axis. Okay, so this is the perpendicular distance, and phi is our azimuthal angle. Okay, so that means अगर हम इस सिस्टम की बात करेंगे, तो फर्स्ट वी आर सेइंग दैट so for circular path z equal to 0, so that means it is the path that is the path जो path यहाँ पे particle की होगी, so that will be circle but at the origin, right? So that means z equal to 0, and this rho is also fixed. So because rho equal to, that's equal to r, because this is simply the radius of that circle. Huh? Okay, so this will be the radius of it. So that means these two are fixed, right? Only the phi is changing because phi is our azimuthal angle, and this is changing from 0 to pi. Okay, so phi is changing here. So from 0 to 2. Okay. Now, so that means here this phi is independent on x and y, right? Because this is very clear. Because when we say that this is rho, so that means if I split this, because if I write this in the component form, so this will be rho cos phi, okay, because this will be the vertical component, and the horizontal component will be rho sin phi. Okay, right? Because this will be the cos component and this will be sin component. Okay, so that means here this phi is, I can say that because from this figure, because this z is constant, z equal to 0, and second that rho, which is the basically the perpendicular distance from the x-axis, so that's also fixed because that's equal to the radius of that circle, right? So radius के बराबर है, so only the thing that is changing, that is basically our phi. But phi we need to say that. So let us have a look on the phi, because we can write that. If I write the different component, because x is our, so that is rho cos phi and y equal to rho sin phi, right? Because from this equation you can say that x square plus y square equal to rho square, because rho is equal to r. So rho किसके बराबर है? That is basically the radius of that circle. Okay. So that means here this phi, it is independent on x and y, and it describes the system completely, because we know the components. यहाँ पे मुझे component पता है. What's our x component? So x component is our rho cos phi, and our this y component is our rho sin phi. So that means once, so this so we know that I am basically writing that x and y in terms of that phi, right? And phi is independent of this, because finally what I am getting, x square plus y square equal to rho square, so there is no phi, right? So that means here phi is basically our generalized coordinate, and it describes the system completely, right? Because once we know that this, we have this x and y in terms of that phi, so we can calculate all these, we can extract all the information regarding this particle. So we can calculate, because once we know the position vector, what's our position vector. तो अगर मैं इस position vector यहाँ पे लिखूंगा, तो r is our, that's xi cap plus yj cap. So x is equal to rho cos phi. Okay, so that means हमें x भी पता है और y भी पता है in terms of phi. So that means position vector is r is known, so we can calculate velocity, we can calculate acceleration, या हम linear momentum भी calculate कर सकते हैं. So that means तो हमें we have complete information about the system, about this particle, right? So that means so far this definition is concerned. अगर हम definition की बात करेंगे, तो ये हमें कह रहा है कि the particles coordinates should be independent on each other, because phi does not depend upon that x and y, right? And second, it describes the system completely. तो क्योंकि once we know the position vector, तो अगर हम position vector की बात करेंगे, तो position vector हमें पता है r is equal to rho cos phi I cap plus rho sin phi j cap, right? तो पोजीशन वेक्टर हमें पता है, तो हम कैलकुलेट कर सकते हैं वेलोसिटी क्या होगी, एक्सेलरेशन या लीनियर मोमेंटम क्या होगा. सो वी कैन से देन phi is our generalized coordinate, because it satisfies both the conditions, that it is independent and it describes the system completely. Okay, so we can say then that here this phi is a generalized coordinate. तो ये हमारा जनरलाइज्ड कोऑर्डिनेट. Okay, so we can say then, so we can say that x is, or we can write this x equal to x of phi and y equal to that y of phi, because it's a function of that phi, right? Okay, or you can write r equal to r of phi, right? Because r is a function of phi. Okay. So second case is that अगर हम और एक एग्जांपल लेंगे, तो हमें देखना है कि so what are, whether these coordinate system are generalized coordinates or not. So that means अगर हम particle लेंगे on a sphere which is moving on a sphere, right? So if I take another example, so a particle okay, so second example is that अगर हम एक particle लेंगे that's moving on a sphere. Suppose we have this xyz coordinate system, x, y, and z, and this is the sphere. So here I'm assuming that, so this is sphere, and the particle is moving on the surface of that sphere. The particle having mass m, and it is moving on the surface of the sphere, and we can specify this motion by, so at any point by x, y, and z, right? And this, if I join, so this basically gives me the radius position vector, or you can say that this is equal to off, you can say. Okay, so that means किसी भी पॉइंट पे अगर हम देखेंगे इस मास को which is moving on the surface of the sphere, right? So we can describe the system completely using these Cartesian coordinates. So one condition is satisfied. So that means यहाँ पे मैं कह सकता हूँ जो हमारा पोजीशन वेक्टर होगा, so this will be xi cap plus yj cap plus z. ठीक है? So this is clear, right? Now, first condition was that this coordinate system they should be independent of each other, right? अगर मैं कोई भी coordinate system use करूँगा, तो we can say that हम कह सकते हैं कि वो coordinate system basically forms a generalized coordinate is a generalized coordinate only when these that coordinate system they are independent of each other. And second case is that they should describe the system completely, right? Because once अगर हमें क्वेश्चन वेक्टर पता होगा इस पार्टिकल का, so that means we can get all the informations, हम बता सकते हैं कि वेलोसिटी क्या होगी इस पार्टिकल की, इसकी एक्सेलरेशन या इसका लीनियर मोमेंटम और एनी अदर वेरिएबल, राइट? और एनी अदर फिजिकल क्वांटिटी हम देख सकते हैं इसका कितना होगा, राइट? Okay, so we can calculate that quantity. Okay, so that means so although it describes the system completely, right? But second case is that whether these Cartesian coordinates are independent of each other or not, because I'm saying that they should be independent, right? But if we say that, because if we have this r square is simply that x square y square plus z square, right? So this is basically the equation of sphere, right? And these are related with each other, right? Because x, y, and z, these are related with each other through this r, right? So I can write that x square equal to r square minus y square minus z square. Okay. Now, okay. So that means we can say that this x, y, z are not generalized coordinates. So GC indicate करता है that's basically the generalized coordinate. तो हम नहीं कह सकते कि we cannot say that x, y, z are generalized coordinates. So what we can do here, because अभी इससे पहले जो एग्जांपल हमारी थी तो वहाँ पे हमने डिस्कस किया था अगर एक पार्टिकल मूव होगा एक सर्कुलर पाथ में, तो हमने फिर ट्रांसफॉर्म किया था फ्रॉम कार्टेशियन कोऑर्डिनेट्स टू सिलेंड्रिकल कोऑर्डिनेट्स. बट हियर यहाँ पे जो हमारा सिस्टम है, तो पार्टिकल मूव हो रहा है ऑन द सरफेस ऑफ दैट स्फीयर. तो जब ये स्फीयर की बात है 3 डायमेंशन, सो दैट मीन्स वी कैन कन्वर्ट दिस कार्टेशियन कोऑर्डिनेट टू स्फेरिकल पोलर कोऑर्डिनेट्स. So that means जो मेरी new coordinate system होगा, so that will be r theta and phi, right? So that means I can convert this Cartesian coordinate to spherical polar coordinate, right? Because we have kind of spherical symmetry. यहाँ पे जो radius vector होगा, that will be constant over the surface of that sphere, because r is fixed here, right? So that means I can do one thing, I can transform that from Cartesian to spherical polar coordinates. So that means we can transform, we can go from, we can shift from Cartesian. So that means अगर हम, क्योंकि हमने ऑलरेडी कहा था कि अगर हम एक सरफेस एक कार्टेशियन कोऑर्डिनेट लेंगे and the motion of that particle on the surface of that sphere, so that is designated by x, y, and z, right? Okay, with radius vector r. Now when we shift from Cartesian to spherical polar coordinates, so that means जब हम spherical polar coordinates की बात करेंगे, spherical polar coordinates, so that means I am talking about that r theta and phi. Okay, so r basically that is our position vector, radius vector, right? And second is theta. So theta, how we can say that? तो पहले हमें थीटा देखना है. तो थीटा बेसिकली हम लेते हैं, तो जो ये z एक्सिस है, तो ये कितना एंगल बना रहा है किसके साथ, with this radius vector, right? So that is basically our theta. So this is position vector and this is our theta. Okay, तो ये हमारा थीटा है. The angle that is made by the z axis with this radius vector, with this position vector. Okay. Second, what we'll do here in order to calculate, क्योंकि मुझे देखना है कि मतलब what are the different components, क्योंकि यहाँ पे मुझे लिखना है कि x, y and z in terms of that r, theta and phi, right? So that means what we can do here, I can draw a projection from this on the xy plane. तो यहाँ पे मुझे projection draw करनी है on the xy plane and take its component, right? So this basically gives me, so this is our that all sine of theta. Okay, so this is our r sine theta, and this will be our r cos theta. Okay, so this is our that r cos theta. Because अगर मैं इसके components देखूंगा तो this is our r cos theta, right? And we need to see what's our r sin theta. R sin theta के लिए मुझे क्या करना है? I need to draw projection from this point on the xy plane, and this will be our that this will be our that this horizontal component of that position vector or radius vector r, right? So this is our r sin theta. This will be our r cos theta. Okay. Now, what's our phi now? So phi is basically the angle that is made by this the projection that we draw on the xy plane with this x-axis. So ये हमारा phi है. So we have now r we denote and theta as well as phi. So because हम क्या है कि so phi is basically it runs from 0 to pi. So we can say that this theta it runs from 0 to pi, and this phi runs from 0 to 2 pi. Okay. तो हम कैसे ले रहे हैं? अगर हमारे पास एक्स वाई प्लेन है तो ये बेसिकली हम कह रहे हैं कि थीटा इज बेसिकली रनिंग फ्रॉम 0 टू पाई, so it is going this way, okay, upper half, and it runs from 0 to pi, so 180 तक. But phi is basically that x-axis it is making the complete rotation, so that means 360, so it is going from 0 to 2 pi. Okay, and let us see now what's our x, y and z in terms of that r, theta and phi. तो उसके लिए मैं क्या करूंगा, तो यहाँ पे जो हमारा प्रोजेक्शन है जो हमने ड्रा किया था इस पॉइंट से ऑन द एक्स वाई प्लेन, तो आप मैं देखूंगा इसके कंपोनेंट्स क्या है along that x and y. So the components, because it is making the angle with this phi, so this will be its vertical component and this will be the horizontal component. तो ये component हमारा हो सकता है r sin theta sin phi, because phi is here the angle, right? And similarly this is our r sin theta. Okay, so this will be, so that means our x equal to r sin theta cos phi, and y will be equal to and our z equal to, because z हमने already देखा था z, so that's our r cos theta. Okay, so that will be equal to r cos theta, because if you calculate that, if I take square of this x square plus y square plus z square, it comes out to be equal to r square. And if we have a look on this coordinate system, spherical polar coordinates, this r is fixed. जो radius vector यहाँ पे होगा from origin on the surface of that sphere, so that is fixed. Radius vector तो fixed होगा, right? Now second is that theta it is running, it is from 0 to pi, and this phi that's azimuthal angle, so that runs from 0 to 2 pi. So phi हमारा वो है जो जब x axis से हम ये rotate करेगा, right? So it makes 360 degree angle. Now, so can we say that here अगर हम यहाँ पे देखेंगे तो जो हमारा पोजीशन वेक्टर होगा, तो जो पोजीशन वेक्टर यहाँ पे है, so that is basically xi cap plus yj cap plus zk cap, so that is equal to r sin theta cos phi right. So this is sorry for the mistake, so this should be sin theta. So this r sin theta cos phi. So the x component, because the x component of this is now x equal to r sin theta cos phi, y component will be r sin theta sin phi, and z component will be r cos theta, right? So that means यहाँ पे हमें पोजीशन वेक्टर पता है, but now in terms of not in terms of x y z, because मैंने कैलकुलेट किया, अब I basically transform this Cartesian coordinates spherical polar coordinates. तो यहाँ पे मैंने देखा जो डिफरेंट कंपोनेंट्स आते हैं वो ये आते हैं, एंड दैट मीन्स मुझे पोजीशन वेक्टर पता है। वंस आई नो द पोजीशन वेक्टर यू कैन टेक इट इज डेरिवेटिव। तो जब हम डेरिवेटिव निकालेंगे वो हमें वेलोसिटी देगा, और अगर वेलोसिटी का निकालेंगे दैट इट गिव्स एक्सेलरेशन, यू कैन कैलकुलेट मोमेंटम। So that means we have complete information about this particle which is moving on the surface of the sphere, right? So that means here, in addition to that, अब हमें देखना है कि जो हमारे कोऑर्डिनेट सिस्टम है, तो क्योंकि r is fixed, only theta and phi is changing, right? तो r fixed है, तो किसी पॉइंट पे भी फिक्स है, right? But can we say that this theta and phi, these are independent on x, y, z, right? Because this is very much clear यहाँ पे आप देख सकते हो, because when we calculate that, when we take square of this, so this is simply that r square, x square plus y square plus z square equal to r square, right? So here we can say that this theta and phi are, they describe the system completely, and second, they are independent of each other. They are independent, right? So that does not depend upon one another, right? So then we can say that this theta and phi are called generalized coordinates, right? So we can say that this and this theta and phi. Okay. Now, so how we can calculate now? In general, how we can write now? So that means यहाँ पे मैं लिख सकता हूँ. I can write that x equal to x of theta phi, or y equal to that. Or I can write that r will be equal to that r of theta. Okay. Okay. So we can say that, because that is fixed here. Okay. So in general, how we can say that? तो हम कैसे कह सकते हैं कि we can say that in general. तो जनरलाइज्ड कोऑर्डिनेट जो होगा, तो जनरलाइज्ड कोऑर्डिनेट विल बी इक्वल टू दैट इज 3n minus n। तो अब कैपिटल N क्या है और स्मॉल n क्या है? सो दिस इट्स अप टू यू, कैन यूज हियर बीटा, राइट? So capital N is the number of particles and n is the number of constraints. So because for the sake of consistency, जो मैंने earlier notation use किया था, I use that beta there. So beta is our constraint and n is basically the number of particles, कितने particles, right? So suppose in above example, अगर हम ये वाले example देखेंगे, a particle moving on the surface of the sphere. So what will be the generalized coordinate for that? So in above example, अगर हम देखेंगे, in above example, so what's our n? N is equal to 1, right? N1 है, right? And how many constraints are there? So constraint एक है, because that radius is basically, that radius vector is fixed, right? So it basically, so you know the what's basically a constraint. Constraint आपको पता है. So only one constraint will be present here. So that will be due to the radius of that sphere. So that means we can say that this generalized coordinate equal to that is 3 into 1 minus 1. So that's equal to 2. So that means जो हमारे generalized coordinates होंगे, those will be 2. Right? Because it's very much clear. Because अगर हम एक particle के लिए देखेंगे, so that's moving on the surface of the sphere. So generalized coordinate will be equal to 2. Okay. And in addition to that, अगर हमारे पास, I will take one more example. Suppose we have Suppose we have two particles on the surface of the sphere. हमारे पास दो particles हैं having mass m. Okay. So that means यहाँ पे अगर मुझे देखना होगा, so how many generalized coordinates for this system, right? तो कितने generalized coordinates? तो first यहाँ पे जो radius vector यहाँ पे fixed होगा, इसका radius vector fixed होगा, right? Okay. So that means यहाँ पे मैं कह सकता हूँ, एक तो यहाँ पे theta है ये, this is our theta, and then this phi is also fixed. So that means for first particle, so theta 1 and phi 1 will be the constraints or general coordinates for mass m2. Or you can say that, okay, better is to write, because I can write here m2 and this m1. तो m1 के लिए जो जनरलाइज कोऑर्डिनेट्स होंगे दो, क्योंकि जब मैंने सेकंड एग्जांपल ली थी पार्टिकल ऑन द सरफेस ऑफ द स्फीयर, तो वहां पे दो जनरलाइज कोऑर्डिनेट्स आते थे थीटा एंड फाई. तो दैट मीन इस पार्टिकल के लिए दो जनरलाइज्ड कोऑर्डिनेट्स आएंगे, तो दैट मीन थीटा 1 फाई 1, एंड सिमिलरली फॉर मास m2 इसके लिए भी दो जनरलाइज्ड कोऑर्डिनेट्स आएंगे, दैट इज थीटा 2 एंड फाई 2. So that means for m1 तो जनरलाइज्ड कोऑर्डिनेट्स क्या आएंगे, थीटा 1 एंड फाई 1, एंड फॉर m2 जनरलाइज्ड कोऑर्डिनेट्स विल बी थीटा 2 एंड फाई 2. So that means कितने टोटल जनरलाइज्ड कोऑर्डिनेट्स आएंगे, so total generalized coordinates for this system, so that will be 2 plus 2, so that's 4. So that means usually, or we can do directly, so we can calculate from 3n minus n, right, because we know that generalized coordinate is equal to, so that's equal to 3n minus beta, so it is 3 into 2 minus 2. वो हम ऐसे भी निकाल सकते हैं, because कितने constraints होंगे, because Rayleigh factor is fixed for these two particles, so that will act as a constraint, right. So for first particle there will be one constraint due to the radius vector, and for this again that radius vector acts as a constraint, right. So that means दो constraints यहाँ पे होंगे, so that beta equal to, and number of particles कितने, because दो particles मैंने यहाँ पे लिए थे, तो उसमें क्या होगा, तो number of particles will be 2, that is 3 into 2 minus 2, so that is equal to, so this is basically the generalized coordinate. तो ये हमारा generalized coordinate है, correct. In addition to that there are many more problems, अगर हम देखेंगे, अगर हम इनको connect करेंगे through some inextensible string, अगर मैं क्या लूंगा, so we have two particles, हमारे पास two particles है m1 and m2, and if I connect them by inextensible, तो अगर इसको मैं string से connect करूंगा, राइट, तो अब मुझे देखने की इसमें कितने जनरलाइज्ड कोऑर्डिनेट्स, राइट. तो पहले हमें पता है कि अगर हमारे पास, तो कितने कंस्ट्रेंट्स यहाँ पे होंगे, एक कंस्ट्रेंट होगा ड्यू टू दिस रेडियस वेक्टर r1, ओके ओके, सॉरी, दैट इज टू राइट r, तो कितने कंस्ट्रेंट्स यहाँ पे होंगे, तो यहाँ पे तीन कंस्ट्रेंट्स होंगे, एक कंस्ट्रेंट होगा ड्यू टू द रेडियस वेक्टर फॉर दिस मास m2, second constraint होगा due to this radius vector for mass m1, so that is 1 plus 1, and one more constraint, क्योंकि हमने इस string से इनको connect किया, because they are interacting with each other, right. तो ये जो system था, there was no interaction between the particles, अगर हम इस particle को bottom में इसको अगर move कराएंगे, तो ये effect नहीं करेगा इसके motion, बट यहाँ पे जो दो मास मैंने लिए, तो इनमें ये these are connected through string, through this string, right. तो string is inextensible, so that means अगर इस particle mass m2 को मैं move कराऊंगा, it will affect the motion of this mass m1, so that means यहाँ पे जो constraint is, so there is one more constraint, so that constraint will be due to this inextensible string, right. So that means कितने constraints, so beta का value यहाँ पे 3 आएगा, so beta will be, so for this case अगर मैं इस केस के लिए देखूंगा, तो बीटा यहाँ पे 3 आएगा and n equal to 2, so that means gc will be equal to, that is 3 into 2 minus 3, that's equal to 3, so that means generalized coordinates will be equal to 3. तो अगर हम if you are interested you can also calculate, तो आप देख सकते हो कि what will be the degrees of freedom for this, तो इसलिए मैंने प्रीवियस लेक्चर में आपको बताया था कि मैक्सिमम केसेस जो है वहाँ पे जो डिग्रीज ऑफ फ्रीडम होता है, दैट्स इक्वल टू द जनरलाइज्ड कोऑर्डिनेट इन मैक्सिमम केस, नॉट इन एवरी केस, बट इन मैक्सिमम केस हम कह सकते हैं कि जो जनरलाइज्ड कोऑर्डिनेट होता है, दैट्स इक्वल टू डिग्रीज ऑफ फ्रीडम. So this was your tutorial second for about these generalized coordinates. Thank you very much.